AI assistants often feel intelligent enough to remember entire conversations just like humans.
But behind the scenes, something very different is happening.
Why does AI sometimes forget information you mentioned earlier? What are tokens, why do context windows matter, and how does AI actually process memory during conversations?
In this video, we will simplify one of the most important concepts in modern artificial intelligence and uncover how large language models really work internally. We will begin by understanding what tokens are and why they are essential for AI systems. Then we will explore how AI models process conversations internally. After that, we will simplify the concept of context windows and explain why they control what AI can remember.
We will also compare artificial memory with human memory and finally explore the future of long-term AI memory systems. Most people think AI reads language exactly like humans do, but internally, AI models process everything using tokens. A token is a small chunk of text that may represent a full word, part of a word, punctuation, or numbers. Before AI can understand your message, the text is converted into these token units. For example, long words may become multiple tokens while shorter words may remain single tokens. This conversion process allows the AI to process language mathematically through neural networks. Every question you type, every answer the AI generates, and every instruction inside a conversation depends on tokens. Token count is extremely important because it affects AI memory usage, processing limits, speed, and cost. Different languages also generate different token counts. Some languages compress information efficiently while others require more tokens to represent the same idea. Understanding tokens is the first step toward understanding how modern large language models actually work behind the scenes. When you type a message into an AI assistant, the system immediately converts your text into token sequences and processes them mathematically. The AI does not consciously understand your message the way humans do. Instead, it analyzes relationships between tokens and predicts what token should come next. This prediction process happens repeatedly until a complete response is generated. The reason conversations feel natural is because the model was trained on enormous amounts of text data and learned statistical language patterns. During conversations, earlier tokens help the model maintain context and consistency. This is why the AI can answer follow-up questions and continue discussions smoothly. However, the system is still fundamentally based on prediction rather than true comprehension. It does not possess emotions, awareness, or biological memory. What feels like understanding is actually advanced pattern recognition operating at massive scale through neural network computations. One of the most important concepts in large language models is the context window. You can think of the context window as the AI model's temporary working memory. It determines how many tokens the system can actively process at the same time. Everything inside this context influences the AI's current response, including earlier prompts, instructions, and conversation history. However, the context window has limits. Once the token limit becomes full, older information starts disappearing to make room for newer tokens. This explains why AI assistants sometimes forget earlier parts of long conversations. Larger context windows allow models to process bigger documents, longer chats, and more complex tasks. Modern AI companies are constantly competing to increase context window sizes because larger contexts dramatically improve usability. Whether it is coding, research, document analysis, or multi-step reasoning, context windows play a major role in determining how capable an AI model feels during real-world use. Many users become confused when an AI assistant suddenly forgets earlier details from a conversation. This happens because most AI systems do not naturally store permanent memory during normal interactions. Instead, they rely completely on the active context window. Once that window reaches its token limit, older information begins disappearing from active processing. In simple terms, the AI literally stops seeing earlier conversation content. This is very different from human memory, where experiences can remain stored for years. AI memory is temporary unless special external memory systems are added. This limitation explains why AI sometimes repeats questions, loses instructions, or forgets details during extended conversations. Researchers are actively developing solutions involving larger context windows, retrieval systems, and external memory databases. But even with these improvements, modern AI still operates differently from human cognition. Understanding these limitations helps people use AI systems more effectively and avoid unrealistic expectations about how AI memory actually works. Even though AI conversations may feel human, artificial memory and human memory are fundamentally different. Human brains store memories through emotional associations, sensory experiences, and long-term neural connections. Our memories continuously evolve over years and influence future decisions in complex ways. AI systems operate differently. Large language models mainly process temporary token contexts and statistical relationships between words. They do not experience emotions, personal awareness, or consciousness. When AI appears to remember something, it is usually because that information still exists inside the context window or was retrieved externally. Human reasoning is flexible and deeply connected to real experiences, while AI reasoning remains computational and prediction-based. This difference becomes extremely important when discussing advanced AI capabilities. Although AI systems can appear intelligent, they still process information very differently from biological brains. Understanding this distinction helps separate real AI capabilities from science fiction expectations. Larger context windows are becoming one of the most important advancements in modern artificial intelligence. A larger context allows AI systems to process much more information simultaneously. This dramatically improves long conversations, document analysis, coding assistance, and research workflows. For example, instead of analyzing only a few pages at once, advanced AI systems can now process entire books, legal documents, or huge codebases within a single context. Bigger contexts also improve reasoning consistency because the model can reference earlier information more effectively. This creates more stable and accurate responses during complex tasks. However, increasing context windows is technically difficult because larger contexts require significantly more computational power and memory resources. AI companies are constantly researching more efficient architectures to solve this challenge. Future systems may eventually support extremely large contexts that feel much closer to persistent memory and continuous understanding. To overcome context limitations, many advanced AI systems now use external memory systems. Instead of relying only on temporary token context, these systems can store important information inside databases or retrieval engines. When necessary, the AI retrieves relevant information and places it back into the active context window. This creates the appearance of long-term memory. Some AI agents already use this approach to remember project details, user preferences, and conversation history over extended periods. Another technique involves summarizing older conversations so important details remain available without consuming too many tokens. These systems are becoming increasingly important as AI applications grow more advanced and personalized. While this still differs greatly from human memory, it represents a major step toward more capable AI assistants. Researchers believe future architectures will combine large context windows with persistent memory systems to create much more intelligent and adaptive AI experiences. The future of AI memory is evolving extremely quickly. Researchers are already experimenting with persistent memory systems, advanced reasoning architectures, and AI agents capable of maintaining long-term knowledge across interactions. Future AI systems may combine huge context windows, retrieval engines, external databases, and advanced reasoning models into unified intelligent assistants. This could allow AI to manage ongoing projects, remember user preferences for years, and maintain continuity across very long interactions. However, these advancements also introduce major challenges involving privacy, security, and responsible AI development. As AI systems gain stronger memory capabilities, conversations about ethical usage and regulation will become increasingly important.
Even though modern AI memory still differs greatly from human cognition, the gap may continue shrinking as technology advances. Understanding tokens and context windows today provides a strong foundation for understanding the next generation of intelligent AI systems. Today we explored one of the most important concepts behind modern large language models.
We learned that AI systems process information using tokens instead of complete human-style understanding.
We also discovered how context windows determine what information AI can actively remember during conversations and why models sometimes forget earlier details during long interactions.
Most importantly, we compared artificial memory with human memory and understood why current AI systems still operate very differently from biological brains.
We also explored how larger context windows and external memory systems are helping AI evolve toward more capable long-term reasoning systems. As artificial intelligence continues advancing rapidly, understanding tokens, context windows, and AI memory will become increasingly valuable for developers, creators, researchers, and anyone interested in the future of intelligent systems. Artificial intelligence is evolving faster than ever, and understanding concepts like tokens, context windows, and AI memory is becoming increasingly important. If you enjoyed this explanation, subscribe for more videos covering AI systems, large language models, future technologies, and advanced AI concepts.
Leave a comment below with the next AI topic you want explored.